Heat capacity! So, what is heat capacity? Well, in simple terms, it's how a material responds when heat energy is added to it. So, basically, heat capacity is the amount of heat energy required to raise the temperature of a substance by 1 degree Celsius. It is important to know that heat and temperature are not the same thing. Heat is the energy in transit, while temperature is the measure of how fast the particles in the substance are moving. So basically, temperature tells us how hot something feels, while heat refers to the actual energy being transferred. From that, we know that two objects can receive the same amount of heat but experience two different temperature changes. That's exactly what heat capacity explains. Another thing to note is that heat always moves from hot to cold. Understanding the equation Q equals mc delta T. Q stands for the heat energy, m stands for the mass, C is the specific heat capacity, and delta T is the change in temperature. Now let's try an equation together. So now that we know what the equation means, let's plug and chug. So the mass is 200 grams, the specific heat capacity is 4.18 joules, and delta T is 20 degrees Celsius. So we know that we need to multiply those three numbers, and then we'll get Q, which should be 16,720 joules. Now you don't need to memorize these, but here are some specific heats of common substances. We just used water in the last equation. Different materials have different heat capacities because of how their particles store and transfer energy. Water has a very high heat capacity, which means it can absorb a lot of heat energy because its temperature rises much. That's why our oceans warm very slowly. Metals usually have a low heat capacity, which means their temperatures change quickly when heat is added. Sand has a lower heat capacity, means that when it's in the sun all day, it's going to heat up faster than soil, which normally contains organic matter and moisture, with a higher heat capacity, because that water in the soil absorbs all the energy without increasing the temperature as quickly, which means sand is going to warm up faster than soil. And we can see this at places like beaches and deserts. Now, here's a real-world example of heat capacity in your everyday life. So, when we get in our car, after a very hot day, we all know that things like the steering wheel and the seat buckles are all so hot, they burn our fingers, they burn our legs, they burn our everything. Well, that's because the metal parts in the car heat up faster because they have a lower heat capacity. So, they're going to be hotter when we get into that hot car. Now, here's an analogy. Imagine feeding the same amount you would normally feed a bobcat to a hippo. A bobcat is much smaller than a hippo and is going to eat a lot less. It's going to fill up quicker, and its energy level is going to change a lot from that food. But for the hippo, that same amount of food is going to be relatively small to what it really needs to get the same amount of energy and have a noticeable difference. Heat capacity works in a similar way, because materials with low heat capacity are like a bobcat. A small amount of energy causes a big temperature change. But materials with a high heat capacity are like the hippo. They require much more energy before their temperature changes significantly. Thank you for watching, and I hope you learned a little something about heat capacity.